Okay, welcome back. And today's lesson number 10, we're looking at application of logarithmic functions. So what's the goal today? I want you to be able to take everything we've learned before, so that would include properties of logarithms and using and solving logarithms, and apply it to the real world application questions. So what you're going to see in the homework, you're going to be looking at homework that you did with the exponential, solving with the calculator, but I want you then, you're going to use logarithms this time to go through and do all the solving. So, quick recall. With the financial, remember the formula that we used looked like this. And again, you just got to look back at your notes to find out what each individual variable stands for. So we're going right back to that last note with the exponential. Your natural sciences, same thing as it was before. And finally, the mathematical modeling, or how I've called it mathematical modeling. It's just a b to the exponent x. So there are the three types of questions we're going to deal with. So yeah, this is going to look very, very similar to the exponential, except now you're using logarithms to solve. We're not using the graphing calculator to find points of intersection. So now I'm using the exact same examples we used before, but you'll notice I changed A and B part. So I'll read it through first here. So Barry has decided to invest $5,000. Okay, so he's investing $5,000 in an account that earns 8% yearly per annum, and it's compounded quarterly. Answer the following. So now with this homework, I'm just asking A part, develop an equation, and then B part, how long will it take the investment to triple? So I don't have you plugging in a value this time. You're just going straight to the logarithmic one. So what do we know? And I'll list the information on the side. His principal, this is how much he has to invest, $5,000. Annual interest rate is R. Please write it as a decimal. And compounded quarterly. So we know the number of periods. So the number of P is 4. So that would mean that my I is going to be 0.08 over 4, which is 0.02. And I know my N is equal to 4 multiplied by the number of years, which is not given, so 4t. So A part, this is identical to what we did before. We know it's a financial app, and we only have one equation that deals with financial. Plugging in the information that we know, A will equal 5,000, bracket 1 plus the 0.02 to the exponent 4t. So there's the answer to A. So on a test, okay, it's all going to be combined together, or the exam I should say, and I'm going to ask you to solve it with logarithms, and I'm going to ask you to solve it with technology. So you need to be able to know how to do it both ways. All right. The reason we do the technology is so that what happens if you're not dealing with logarithms? What happens if it's another type of function? It carries over. So when you run into new and different functions, if you're going through in college or university, you then aren't intimidated. You know you have a technology that you can fall back on. But in this case, we are going to be focusing on logarithms for this upcoming test. So how long will it take his investment to triple? So that means the amount is going to be 3 times greater than what he put in. So now it's going to be 15,000. So plugging into the model, 15,000 equals 5,000, 1.02 to the exponent 4t. We're trying to solve or isolate for t. So guess what? Same thing you were doing with the calculator, I still recommend doing here. Let's divide both sides by 5,000 to start. Okay, reduces the size of the number that we're working with. So now we have 3 equals 1.02 to the exponent 4t. If you look back at yesterday's homework, this was one of the earlier questions that you were doing. How do you solve this? Well, you take the log of both sides. So log of 3 is equal to the log of 1.02 to the exponent 4t. So I'm going to use the same, I'm going to put all the steps in here, and you can skip the steps that you're comfortable skipping. The exponent rule, when you're dealing with logarithms, means that 4t can come out front. 1.02. And now I want to isolate for t. What's happening to t? Well, it's being multiplied by 4, and it's being multiplied by the log of 1.02. Inverse operation for multiplying is division. So I'm going to divide both sides by 4 log of 1.02. And by doing that, we've isolated, or we're isolating for t. So the 4 would get canceled out, inverse operation, inverse operation. So your final answer then would be t equals log 3 divided by 4 log 1.02. All right. What that does is it gives you an exact value now. You're not worrying about approximating. And I'm going to go grab a calculator here just to punch it in. So plugging it into the calculator, you get 13.9. So therefore, it will take, say 14 years for Barry's investment to triple. Now, the calculator gives you pretty close, and if you compared the answers here, you would find that if we're only going to 2 or 3 decimal places, it's probably the exact same. But if you go further, you'll notice the graphing calculator's answer and what we came up with the logarithmic expression here is a little bit different. And that's because this is an exact value. Okay, this is an exact value. When the calculator is trying to find the intersection of 2 lines, like we were doing before, we were looking for that point of intersection, it does what we call an iterative process, and it's basically guessing and checking. So it'd be the same as you creating a table of values and just guessing at the answer. So this provides a more exact answer. All right, so the ant farm question then. He has an ant farm. Colony starts at 25, and the growth rate is now, I changed it to 48%. So I did change the question a little bit to make it a bit more exciting. So we have 25 ants, 48% in population per year. So this is your mathematical modeling. Like I said, if you see a base or a percentage growth rate, then you know you are dealing with that base mathematical model. So A part, base mathematical model looks like this. So f of x equals, A is your initial amount, so the number of ants. Now we have a 48 growth rate. So that means with growth, that means we're increasing. So you have 100% of last year's ants plus 48% more of this year's ants. So 1.48x. So there's your answer to A. There is the equation that models the situation. So B, we're asked when will f of x equal 1,000? So we have 1,000 equals 25, 1.48 exponent x. Again, I would still recommend dividing by 25 on both sides. I think it's a more simple way or a more simple approach to this question or for the solution. So we end up with 40 equals 1.48 to the exponent x. And now we're down to the homework from yesterday. Take the log of both sides. And now, hopefully by now, you're comfortable saying the log of 1.48x to the exponent x is simply x log of 1.48. So you're comfortable skipping that step and realizing with the exponent law, the exponent is going to appear out front as a coefficient. Now we just need to isolate for x, 1.48. If you still need to put that intermediate step in, there's no problem. There's really no penalty. You're not going to get punished for doing that. So don't be afraid if you still want to do that, or go ahead and do it. So we get x equals log 40 over the log of 1.48. Now, while I'm doing the calculation here, I will mention there's many more. I've only done a couple of the examples that exist out there for logarithms. The reason I don't go into stuff like Richter scale or some of the pH stuff is that if people haven't taken any of the physics, if people haven't taken any of the chemistry, it becomes more complicated. I know people have done the financial. You've done exponential like this in the grade 11 course. So I'm sticking with the more simple examples, because if you don't have a background understanding of physics and chemistry, it can be a little bit, that becomes more the trouble than the actual math. So there are more applications that they had measured before. Same thing with sound. Decibel levels are logarithmic. but unless you have an understanding of sound, intensity, and so on and so forth, it just, the question, you just memorize a process, and I don't want that. So wait, if you're going to go into an area that requires it, then you'll end up doing that. So, Greg, we'll have to wait. And in this case, you can go 9.5 years, or you can put the 9.4 in. Okay, 9.5 years. All right. What do we have next? I think we have the uranium question, which I have time for, and then I think I'll leave it at that for you. I won't do that extra example again. So A part, this is a natural science question, so it's going to be AB to the exponent x over t. So f of x equals, our initial amount is 150 grams, so he has 150 grams of radioactive material. It takes 80 days for it to decay. It's a half-life question. Half-life question. So we get x over 80. So there's our model. Whoops. Losing control here. Absolutely losing control. Wild. There we go. There's A part. B part. So determine how long it will take to get to 1 gram. So you're asking, you kind of assume things get harder as you go through a unit, but you're through the hard part. The properties and solving logarithmic equations, much more challenging than the application, because the application tends to be the easier solving equations. So for this one, you can go ahead and solve. I still recommend in this case, it's nice to isolate. So I'm going to divide both sides by 150. So I'm going to fraction. Fractions don't really matter. I mean, you should be comfortable dealing with them at this point. Take the log of both sides. So the log of 1/150th equals, again, x over 80 log 1/2. A little bit trickier here with the algebra, and I'll slow the steps down for you. What's happening to the x? Well, it's being divided by 80. So that means inverse operation would be to multiply by 80. So using your inverse skills, we'd end up with 80 log 1 over 150 equals, so multiplying by 80, cancel the dividing by 80. So now we have x log 1/2. If you're comfortable doing all this in one step, that's fine. I just wanted to show or remind people of how this inverse operations work when you're dealing with the algebra. 1/2. If algebra is a problem, hopefully we took care of it when we were going through solving equations. So x equals 80 log over 1 over 150 log of 1/2. And I'm just going to pause it, plug in the equation. Oops, not what I wanted. So what we get here, we get 578 years. So therefore, it will take 578 years to reach 1 gram. All right, so there we go. Like I said, I'm not going to bother with that example here, and the homework is down here. Okay, and yeah, the questions are going to look fairly familiar, except I took out the ABC part for you. You're just going through and solving using logarithms, and it's very, very important that you're comfortable with that. And that's the extent of what we're doing with logarithms. So if you were good with solving equations, today we'll just be reviewing and going through and making sure the variables are correct. So good luck. If you have any questions, you know where to find me.